Hey, time to analyze math and history, and we're going to learn about something that's called an arithmetic sequence. So right over here is a sequence, meaning that there's some kind of pattern that we see, but we have to find out. What we need to do is try to find the first two A's. Then, without further ado, try to find the equation in its explicit form. So let's get started. We're going to say and assume we start right there. So we have turn 1, turn 2, turn 3, turn 4, and turn 5. Now we got to find something that works out. So what do you see each time you make a turn? Yeah, what we really see is we start here, the distance is 5. The distance is 5, the distance is 5, and the distance is 5, and the next is assumingly supposed to be 5. What that says, for each time you make a jump of 5, that we can say A1 is going to equal 1. A2 is going to equal 6. A3 is going to equal 11. Okay, we found some kind of numbers, but what about the equation in its explicit form? Well, what happens is, we know that each time we make a turn, we go by 5. And we're going to say the number of turns is the letter n. So here's what happens. When you have an output for the number of turns, that is going to be equal to 5 as the jump in turns, but we're still missing something. We're still missing the start position. But can you say 1 as a start position? Not exactly. What we can do is we kind of have to go the opposite way. Because what if your teacher said that wasn't the start position? What is, for example, A to the start where A1 is not the first number? What we have to do in that case is go back by 5. So 1 minus 5 is negative 4. And this is the equation in its explicit form. Hey, does this remind you of something? Well, to me, it actually kind of does. That formula right there reminds me of the formula right here that we've been experimenting in the past 4 years. You learned about this in middle school and in high school, which is a fundamental thing you need to know for calculus. But y equals mx plus b. Okay, this arithmetic sequence is very, very basic. But to take it up to the next step, we're not going to focus so much on y equals mx plus b, because in calculus, it's not really, you do need it to understand other things, but it's not like talked about a lot in calculus. So for an arithmetic sequence, mathematicians love to use something else that we do. Yeah, we like to use the linear function. Wait, the linear function, what we're trying to say here is the point slope formula. That's weird. So it's going to be point slope formula, where you probably learned, which you probably should have, y minus y1 equals m times x minus x1. And the formula is useful because it helps you try to find the formula when you are given a point and a slope. You're trying to find what that y equals mx plus b thing is. But what about this formula right down there? Turns out that there's a conversion between these two formulas. We added y1 here and then moved it right over there. Okay, the problem stays the same where y is isolated. but there is something else that we found out. This bottom one. So right here, since we're learning about the beginning of arithmetic sequences, and also this could be used to understand the logic for a computer science course at a beginner level, instead of y, mathematicians use the letters a and n. It's going to equal what's d, and what's n? Minus 1 plus a1. Okay, this formula on the bottom is hard to explain just by itself, so we need to think about something that will help us out. We do know that the point slope form and this are the exact same thing, but in computer science, the bottom one is how it's conveyed. Okay, what can we do about the d, the letter n, and the a? What we can do is think of d as the slope, or aka a constant difference. If you have two values and you try to find the distance, literally that's what it does. Where here is an example part of the formula, where your am is going to equal 5 multiplied the number of terms subtract by 1 plus 1. That is going to represent your am, and that's going to be your start position. So the 5 in this case scenario would be known as the slope. And when you circle it, it connects to the letter M right here, the letter M right here, and the letter D. But instead of M, we use D because it literally means constant difference, which makes it a lot easier. So now we understand what all that stuff is. We're going to try to think this point slope formula and apply it to this. So right over here can be a little bit confusing because there are literally no numbers that we can find. Instead of trying to find the sequences like we did over here, what we're going to try and find is try to look for this formula right here. So what can we do? What we can do is pull the formula, put it into here, and try to put these things onto the piece of paper. So we know that we begin of a subscript to number of terms. That is going to be equal to d negative 1 over 2 multiplied by the number of terms minus 1. Then we have our y-intercept. Well, the y-intercept, which is 12. So we're going to add plus 12. The n minus 1 is always going to be the same and will never ever change, so we don't really have to worry about that. But the bottom one is a little bit more tricky because it's not a1, it's a6, and we have a d of 3. But what do we do to find the a6? Well, we have a6, we need to find a1. And we know that the slope in this case scenario is 3. So, to get from 6 to 1, we have to multiply 5 times and do 30 minus 3 times 5 is 15. So 30 minus 15, which is 5 turns, is going to equal 15. So in this kind of logic, we get a m going to equal 3, because that is how many times you jump per turn, n minus 1, then we add the 15, which is the y-intercept in this case scenario. So what we did is we understood how to take the point slope formula and understand if you are given an A and a D, but you're never really given a sequence, you can make up the sequence. But if it's simple like this, the teacher in the math problem will ask you to find the point slope formula. So yeah, if you see this, then you still do it, but manually try to observe. If you see this, if it gives you parts, great. If it gives you this, try to find the A1, how many jumps per turn, and this is what you get. So yeah, I hope this video has helped you understand arithmetic sequences. Thank you for watching Helping Analyze Math Industry. Like and subscribe!